In this lesson, we will learn to calculate between pH and H+ concentration and POH and OH- concentration, and also how to convert among pH, POH, hydrogen ion or H+ concentration, and the hydroxide ion or OH- concentration for a given solution. Remember that a set of square brackets represents concentration. When we see the brackets around H+, we read that as concentration of H+, or the brackets around OH- means the concentration of OH-. This is typically in units of molarity. Acidic solutions have an H+ concentration that's very low, such as 10 to the minus 5 or 10 to the minus 9th. As a result, we're dealing with very small numbers. To avoid this, we're going to see that we measure it in terms of pH. And this is just going to be a way to convert from H+ to pH, and it still shows us the exact same information, just in a different format. When we have a solution that has a pH greater than 7, we know we are dealing with a basic solution. When pH is equal to 7, it's a neutral solution. And when pH is less than 7, we have an acidic solution. The diagram shows examples of various solutions and their pH. To actually calculate pH, we're going to use a log function. So pH equals the negative log of the H+ concentration. Remember that H+ and H3O+ mean the exact same thing, so these are used interchangeably. It's important that you learn how to do these calculations on the calculator that you will use on the exam. Calculator models can function differently. In some calculators, you can simply type the negative sign, log, and enter the H3O+ concentration. On other calculator models, you need to type in the concentration first, then hit log, and then hit the minus sign. If you need help with your calculator, please don't hesitate to ask. A logarithmic scale is different than a linear scale, and a change in order of magnitude changes the value of a log by only one value. When we look at values of H+ concentration and the corresponding pH, what we notice is that when the exponent is 0, the pH is equal to 0. For an exponent of -2, we end up with a pH of 2. For -4, we get 4, and this pattern continues. This is a good way to approximate the pH value you're expecting to make sure you're doing your calculation correctly. Changing it from a different number than 1.0 will change the value, but it will still remain close to that exponent value. Like we had to worry about significant figures when dealing with addition, subtraction, multiplication, and division, we also have to look at the significant figures in logs. The number of sig figs in the concentration will equal the number of decimal places in the pH. Let's also use this as an example to see if you can calculate the pH correctly using your calculator. We have pH equals the negative log of the H+ concentration, which is 3.5 times 10 to the minus 3, and we end up with 2.46. If you're not getting this value, please ask for help with your calculator. What is the pH of a solution with H+ equal to 3.2 times 10 to the minus 3? pH equals the negative log of the H+ concentration. pH equals the negative log of 3.2 times 10 to the minus 3. And we get a pH equal to 2.49. The relationship that we see in pH is not exclusive to those values. Just as we have pH equals the negative log of the H+ concentration, we can also have POH equals the negative log of OH-, the pKa, which we'll see later, equals the negative log of Ka, and even the P of your age equals the negative log of your age. We can substitute anything in for the H and the H+ as long as they match each other.